So hello student, let's start the next topic of our discussion in the discrete mathematics, that is logical operations and the logical connectives. Okay, so you might be know about the connectives in the English language. Basically we are using and or as soon as such kind of connectives in our day-to-day life. Okay, so the phrase or the word which combines simple statements are called a logical connective. So guys, this is very simple definition. Whenever we use a connectives, there should be a two simple statement, and to combine those two simple statement we basically use a connectives. Okay, so in the logic we basically have a five types of connectives. Okay, so see here, the first connective is or. Okay, so you might be know about this or connective. Okay, so the symbol of or is a V symbol. Okay, and this or is the compound statement called it as a disjunction. Okay, so whatever the compound statement we will get after the using this or connectives, that statement called as disjunction. Next connective is and. Okay, so this is called a reverse V. Okay, so this is a type symbol, but this is not a. Okay, so this is a symbol of and. Okay, and the compound statement formed by the and connectives called as a conjunction. Okay, so this is called a conjunction whenever you are using and connectives. Okay, next connective is not. Okay, so if you want to take a negation of any statement, in that case you use not connectives. Okay, so the symbol of not is like this. Okay, so this is the symbol, or you can give a tilde sign also. Okay, so the compound statement called as a negation. Okay, so if you want to take a negation, then you can use not. Okay, the fourth connectives is if then. Okay, so this is the arrow symbol is used for this type of connectives where conditional or this implication. Okay, so this is the conditional statement you are getting after using this symbol or using this connective. Okay, so if means the statement 1, and then after then you can write a statement 2. Okay, to combine these two statement you can use this symbol. Okay, next fifth connective is if and only if. Okay, so this is the bidirectional symbol. Okay, so bidirectional arrow, it is the symbol of if and only if. Okay, and the compound statement called it as a biconditional. Okay, means if then statement 1, and only if then statement 2. Okay, so you can write if and only if like this using this symbol. Okay, so let's continue the discussion on this topic one by one. Okay, let's start with the conjunction. Okay, if two statements are combined by the word and. Okay, so I am talking about conjunction guys, and statement. Okay, to form a compound proposition, then the resulting proposition is called a conjunction of two propositions. Okay, so conjunction कब बोलेंगे, जब आप एंडिंग करोगे दो सिंपल स्टेटमेंट्स के बीच में. Okay, symbolically, if P and Q are the two simple statements, then P and Q denotes the conjunction of P and Q is read as P and Q. Okay, so how you can read this statement P and Q? This is the AND operator guys. Okay, so let's understand this conjunction with the help of truth table. Okay, so here you have a truth table. This is the P statement, this is the Q statement. Okay, and this is the value of this proposition P, and this is the value of this proposition Q. Okay, if P is true and Q is true, you will get the result P and Q is true. Okay, if P is true and Q is false, then you will get a false result. If P is false, Q is true, then only you are getting a false result. If P is false and Q is false, then P and Q will give you a false result. Okay, basically if you carefully observe this table, then you will get one basic idea. The statement is false. The statement is false if any one of the simple statement is false, or if any one of the proposition is false. Okay, I hope you are getting my point. Okay, so this is called a conjunction. Okay, so the simple, if anyone is false, then it is false. Okay, if both are true or all are true or the simple statements are true, then only P and Q, you will give you a true statement. Okay. Next is disjunction, guys. A disjunction, any two statements can be connected by the word or, okay, to form a compound statement called disjunction. Okay, symbolically, if P and Q are the two simple statements, then P or Q, okay, this is the symbol of or, okay, denotes the disjunction of P and Q, is read as P or Q. Okay, so how you can read this statement P or Q? This is the symbol of or. Okay, let's understand this disjunction with the help of truth table. Okay, so this is the P proposition and this is Q proposition, and these are the values of this proposition. Okay, so if P is true, Q is true, then you will get P or Q is true. Okay, if P is true, Q is false, then you will get P or Q true. Okay, if P is false, Q is true, then only you are getting P or Q is true. And if P is false, Q is false, then you are getting P or Q is false. Okay, just observe this table carefully again, and you will get an idea that if any one of the statement is true, then your result is true in the disjunction. Okay, if any one of the statement is true, then your result is true in the disjunction. So this is a very easy way to understand this or to remember as this, that in the disjunction, whenever any one of the statement is true, then your result is true. Okay, but in the conjunction, what happen? If any one of the statement is false, then everything is false, or the result of this combined statement is false. Okay, so this is the conjunction table and this is the disjunction table. Okay, now next is negation. Okay, so given any proposition P, another proposition called a negation of P. Okay, means if you have a proposition P and another proposition that is called a negation of P can be formed by modifying it by not. Okay, so you need to use a not word whenever you want to convert any proposition P to a negation proposition of P. Okay, also by using the phrase it is not the case that, it is false that. Okay, so instead of not, you can use this is the phrases, these are the phrases are given. It is not the case that, it is false that. Before P, we will able to find the negation. Okay, so using this word not or these phrases, you will get the negation of P. Okay, symbolically negation P reads as not P. Okay, so this kind of tilde symbol you are getting whenever you want to write a negation of any statement. Okay, and how you can read this? This is you can read like not P. Okay, or negation of P. Okay, denotes the negation of P. The truth value of negation P depends on the truth value of P. Okay, so definitely the value of negation P is completely depend on the P. Why? Because you are taking a not of that P. Okay, see here, here you have a proposition P and here you have a negation of P. Okay, so if P is true, then definitely negation of P is false. Okay, because you are taking a reverse of that. Okay, so P is true, then negation of P is false. If P is false, then negation of P is true. Okay, so this is very simple to convert that. If this is true, then this is false. If this is false, then this is true. Okay, this is very easy to convert. Okay, the next logical connectives is a conditional or the implication. Okay, so this is called as a if and then. Okay, so if after that statement and then after that next statement. Okay, let's see here the theory part. If two statements are combining by using the local connectives if then the resulting statement is called a conditional statement. So as we know, whenever we connect two statements with the or, we called it as a disjunction. Okay, and whenever we connect two statements with the and, then we called it as a conjunction. Okay, like that, if we are using this if and then that statement is called the conditional statement. Okay, see here, if P and Q are two statements forming the implication if P then Q. Okay, that then we denotes this implication P arrow Q. Okay, so this is the arrow symbol for if and then. Okay, if P then Q. So P is the basically a condition. Okay, so it's depend, the value of Q is depends on the P. Okay, what are the P are giving, means you are using into the program or into the mathematical statement. Okay, P is called the antecedents or the hypothesis. Q is called a consequent or the conclusion. Okay, so P called it as the antecedents or the hypothesis. Okay, so whatever the assumptions we are doing, whenever you are solving any problem, then that is called P. Okay, and Q is your result basically. Okay, let's understand this with the help of the truth table. So this is the truth table for the conditional and implication or the implications. Okay, so these are the P proposition and Q proposition, and P implies Q. Here you have P implies Q. You can read it as a P implies Q. Okay, if P is true, then Q is true, then this is true. Guys, P statement true, then Q statement is also true, then your result is also true. Okay, P is true, Q is false, then your result is false. Okay, means if P is true and Q is false, then your result is false. Okay, if P is false, then Q is true. In that case also you are getting true here. If P is false and Q is true, false, sorry, then your result is true. Okay, so you just observe this table. You are getting only one false statement when if P is true and Q is false. Okay, means the condition true and then Q is false. In that case only you are getting false as a P implies Q. Otherwise everything is okay. Otherwise everything is okay, because if condition is true, you are then the part is also true. If condition is false, then part is true. That is a might be a case. That's why P implies Q is also a case. If P is false and Q is false, that is a genuine thing. Okay guys, so this is also true, but this is a wrong statement. Means if you conclude or if you taking a meaning of this statement, that is P is true, still you are getting Q as a false, then this statement is false guys. Okay, so this is the only case where you are getting a false in P implies Q. Okay, so T true, false, then you are getting false. Okay, so see here, conditional and implication. Since the conditional statement play an essential role in the mathematical reasoning, a variety of the terminologies is used to express P implies Q. Okay, so these are the different terminologies are used in the mathematics to represent P implies Q. So just see here or just read once again, one time first. If P and Q, P implies Q, P only if Q, Q if P, P is sufficient condition for Q, Q when P. Okay, so P, Q is necessary for P. Okay, or Q follows from P. If P comma Q, Q unless negation of P. Okay, so these are all the representations basically we are using in the mathematics for P implies Q. Okay, so basically you just pick up one thing. Okay, P implies Q, that's it, that is enough. Okay, so you need not to remember all these things, but if somewhere this kind of things are appear into the question, then you will able to get what it is mean. Okay, means P implies Q is similar to these examples. Okay, okay, so there are some identification or there are some different types of implications. Okay, so basically this is also a conditional or the implications, but the type is different. Okay, means this is you can say that a equivalent statement of P implies Q's. Okay, so see here, converse, inverse and the contrapositive of the conditional statement. Okay, we can form some new conditional statements starting with the conditional statement P implies Q. that occurs so often. Okay, so whenever means this kind of things, P implies Q occurs most of the time. Namely, okay, so namely converse, inverse, and contrapositive, which are follows. Okay, so see here, converse. If P implies Q is the implication, then Q implies P is called the converse of P implies Q. Okay, so if you want to take a converse of P implies Q, then what you need to do, you just need to take Q implies P. Okay, you need to take just reverse. Okay, P implies Q का reverse आपको Q implies P करना है for the converse. Okay, for the contrapositive. Okay, so if P implies Q is the implication, then the implication negation Q implies negation P is called a contrapositive. Okay, so we will see the contrapositive proof technique. In that case, you will this statement is very beneficial for us. Okay, so if P implies Q is the implication, then the implication Q negation Q implies negation P. Okay, this is called a contrapositive statement. Okay, what is meant by inverse? Okay, so see here, if P implies Q is the implication, then negation of P gives negation of Q. This is called the inverse. You know guys, the inverse means what? Inverse means taking a negation of anything, any element or any numbers. Okay, so see here, P implies Q you have. So what is the negation of this? Negation P gives negation Q. This is very simple guys. Okay, so you just need to take a knot of P and knot of Q to achieve the inverse. Okay, so you just need to remember what is converse, what is contrapositive, and what is inverse. Okay, over the P implies Q. Okay. Next thing is biconditional statement. Okay, so this is another last logical connectives we need to study here. Let P and Q be the propositions. The biconditional statement P double arrow Q is a proposition. P if and only if Q. Okay, how you can read this? P bidirectional arrow Q. P if and only if Q. Okay, the biconditional statement is true when P and Q have a same truth value. Guys, this is very important. Okay, the biconditional statement is true when the P and Q have a same truth values and it is false otherwise. Okay, biconditional statement are also called by implications. Okay, so P implies Q is the just a simple implications, whereas P bidirectional arrow Q implies by implications. Okay, it is also read as P is necessary and the sufficient condition for Q. Okay, so this is the again new English sentence to read this kind of statement. Okay, P is necessary and a sufficient condition for Q. Okay, let's understood this biconditional statement using the truth table. Okay, so this is the P proposition, this is the Q proposition, and here we have the value of P by conditional Q. Okay, so the P is true, Q is true, then you are getting true. Okay, so see here, the biconditional statement is true whenever P and Q have a same truth value. Okay, so here true we have, that's why I am getting true here. Okay, here P is true, Q is false, then definitely I will get a false because these two values are different. Okay, see here P value is F, Q value is T, definitely I will get F here. Okay, because the value of P is different and value of Q is different than P. Okay, now next is P is F, Q is F, the value of P and Q is same, then definitely in the biconditional I will get a true. Okay, so just remember this statement, biconditional statement is true whenever P and Q have a same truth values. Okay, let us just revise once again. So first we have seen conjunction. Conjunction means AND statement. So in the AND statement, if anyone is false, then it is false. Okay, means everything is false. Okay, next we have seen the disjunction. What is in the disjunction? OR statement. So in the OR statement is if anyone is true, then it is true, means everything is true. Okay, next we have seen the NOT statement. NOT statement means just you need to take a negation. If the P value is true, then the negation of P is false. Okay, then we have seen the if then. Okay, so in the if then only the true false will give you the false value, otherwise everything is true. Okay, means p value is true and q value is false, then only you are getting a false value in p implies q. Okay, and in the biconditional statement, if the truth value of the statements are same, then only you are getting a true value. Okay, otherwise it is false. Next is the precedence. Okay, means if any statement you are getting a multiple operators, okay, means in the one statement you are getting and or implications, then what is the sequence to solve this problem or to solve this operators? Okay, so first of all you need to solve the not operator, the precedence is 1, then ending, then oring you have to do, then implications. Okay, if then statement you have to solve, the precedence is 4, and then at the end you need to solve the biconditional statement. Okay, the precedence is 5. Okay, so this table shows you the precedence level of logical operators. Okay, in the next lecture we will see the logical equivalence between the statements. Okay, thank you.